Vibe coding has been a flawed concept from the start. Even if humans tried to code this way, they'd fail and encounter the same problems AI does. But the way that humans get it done is through something called spec-driven development. Now, in simple terms, SDD means that you clearly write out the exact specifications of the system, and only then do you proceed. Here, in this case, you could be the stakeholder of the project with your AI agents being your devs. You need to be on the same page in terms of specs. There have been a lot of implementations of this workflow, but GitHub actually released their own toolkit for this type of development, the GitHub Spec Kit. The name of the GitHub Spec Kit is Specify. It has a complete workflow built in with prompt refining and multi-agent workflows as well. But before heading into all that, I'm going to quickly show you the setup process. To install it, you can just copy this command and run it in your terminal. I already have a project running with the Spec Kit, and I'll be using this to give you a walkthrough of the whole workflow. In the install command, in place of project name, enter the name of the project you're going to initialize with this toolkit. After that, it's going to ask you to choose your AI assistant. Currently, it only works with 3: Claude, Gemini, and Copilot. I'll choose Claude Code here, and it will go ahead and put all the files in the directory. Now we have our demo project with all the necessary files. If I navigate into the demo project, you'll see a scripts folder and a templates folder. These are important components in the working of this system, but don't worry. I'll explain what these are later on. Since we selected Claude Code as our coding agent, we're going to open that up to start the workflow. If I open up the /command menu, you'll see the 3 main commands we're going to use: plan, specify, and tasks. These are the 3 main phases of development with this toolkit. Now, after using this workflow, one thing I've realized is that this system is actually just for implementation. For example, these 3 commands are only for implementing the code. They don't really handle the context engineering behind it. The specify and plan commands do expand your idea, but they don't actually do the full planning. So for the planning, I used ChatGPT. I told it that I wanted to make a content management system for this YouTube channel, explain the different types of content that should be in it, what the workflow was supposed to be, and how I wanted the content to be organized. It gave me this requirements prompt. Once you get your requirements, you give them to the spec kit so it can expand them into a complete spec document. This spec development could be for a whole project or a feature like authentication in an existing project. To start the workflow, we come to the first phase using the specify command. You run specify and provide your project requirements. If it's a feature, it will build accordingly. If it's your whole product, it will build for that instead. The command then creates a product-specific specification and makes a new branch for the implementation. This happens because feature implementation in existing projects needs separate branches for version management. The command creates product specs that outline the main features of that implementation. For example, this is the spec for this feature branch. We have the execution flow, the user journey, edge cases, and other requirements. Regarding prompt refinement, if the agent identifies areas where it's confused or needs more detail about the project or feature, it marks them. At the end of the generation process, it asks you about these areas. In my case, there were 4 areas needing confirmation. I provided my answers and specified everything. Looking at what it changed, you'll see it adds a needs clarification flag, followed by the required detail. It inserts these throughout the spec, highlighting questions we need to answer. After I responded and updated it, that part of the process was completed. Another unique thing about this spec kit is that it includes executable scripts, meaning a lot of the setup isn't left to the agents themselves, but is handled by scripts that run at specific points in your process. If we look at the scripts, during the first specify command, it runs the create new feature script. This script first finds the next feature number, allowing you to construct a whole product or work feature by feature. It checks the previous feature number, so if we have 001, the next must be 002. It then creates a new Git branch and a new directory for it. You can see we have our own folder for this 001 feature. The script sets up all the files specific to the feature. The spec.md is specific to this feature, and if I were to make another feature, it would have its own spec. We have curated templates available so it doesn't need to create everything from scratch. In this case, we use the spec template, and you can see the rest of the templates for the other phases of the process. If you're enjoying the content, please consider hitting the subscribe button. We try to get better with every video, and your feedback in the comment section always helps us out. After the specify command comes the second phase, the plan command. While the specify command focuses on writing specifications, defining features, user experience, and general app usage, the plan phase shifts to technical implementation. For this step, the system needs certain details. As mentioned earlier, this agent doesn't handle planning or research for you. It takes data directly from you, so it won't help brainstorm or research the tech stack. You could ask Claude Code, but it won't be structured. So once again, I went to ChatGPT. Essentially, this outlines what's required for every feature implementation. I told ChatGPT my requirements, and it provided a structured set of requirements for my specific implementation. I then adjusted some according to my needs. As you might expect, this spec kit targets developers rather than vibe coders. From there, it began planning the content management system implementation. When we run the setup plan script, the directory and spec have already been created in the specify command. Now we need to create the plan template and related files. First, it copies the plan template, then generates the necessary files based on command instructions and planning. These files are specific to the plan stage of implementation. Your spec contains feature details, while the plan contains all technical implementation details. After this, you start implementation by breaking it down into manageable steps. Here you can see the implementation plan for the 001 branch is complete, with all documentation set up. It then automatically prompts you to run the tasks command to generate implementation tasks and outputs the task count. However, as you'll see shortly, the actual implementation ended up having many more tasks. Now, moving on to the third phase, we start by running the tasks command. This takes the implementation plan and breaks it down into small executable tasks. First though, it runs the check task prerequisite script. This script verifies that you're still on the same feature branch and confirms the plan.md file exists. It then gathers all available design documents and the documentation from the previous step, returning these to your agent, which in this case is Claude Code. This allows the agent to read them and generate our tasks. You can see it pulled the key design documents and read them one by one. After processing everything, it generated tasks in our task.md file. We had 93 tasks total, organized into 9 phases. Of these, 47 were parallel tasks that could run simultaneously. The 9 main phases are listed here. The system created an extensive task list because many tasks are parallelizable. In the first setup phase, only 2 tasks can run in parallel. Later in phase 3.2, we write out our tests, which is fundamental to spec-driven development. You write tests before moving forward, so if any fail, you fix them immediately. As you add code, these tests can also run repeatedly through CI/CD pipelines, ensuring new code doesn't break existing functionality. One limitation I discovered is that all tasks must be run manually. I couldn't find a way to have the agent implement tasks automatically, so you need to instruct it on each task individually. However, many tasks can be parallelized. Since Claude Code supports sub-agents, tasks 3 and 4 ran in parallel. Sub-agents handled them, and despite each taking considerable time, running them simultaneously saved time overall. Sequential execution would have taken 40 minutes each, but parallel execution completed both in about 40 minutes total. And this is the application it ended up creating. The Notion theme was followed, and the ShadCN components were all implemented correctly. But as far as the layout and UI, that wasn't really done properly. Other than that, I tested it out. The functionality of the app does work, so that's good. Everything has been linked together well, so the functionality is fully implemented. But I think that to make the UI better, I might need to open up another feature using this process to actually fix the mess. Right now, it looks kind of cluttered. That brings us to the end of this video. If you'd like to support the channel and help us keep making videos like this, you can do so by using the super thanks button below. As always, thank you for watching, and I'll see you in the next one.